Hi everybody. Today my topic is the spectral analysis. Basically, the spectral analysis allow to describe some phenomenon like variation of velocities, accelerations or displacement depending on periods, pulsations or frequencies. And the main use of this spectral analysis in robot is to describe the seismic action on a structure like this. So let's start. Click on analysis, choose analysis type, then click new. Here analysis type, it must be model. So click OK. So 7 will be added as model. Now in this modal analysis parameter, number of modes. Basically number of modes, it depends on the type and complexity of the structure. So looking at this structure, we can think of what will be the value. Say it is 6 stories, so surely we can put here like 3 times, say 18. Now regarding mass matrix, it is consistent, lumped with rotation, lumped without rotations. So what it is? So let's bring this and see how it looks. So this is the thing. Consistent, it means mass is distributed uniformly along this element. You can see the on element how it looks, and it is very clear what is consistent. But in case of lumped with rotations or lumped without rotations, one thing is common, that mass is distributed only to nodes. It is for both cases, mass is distributed only to nodes. But this one with rotations and this is without rotations. So let's move for active mass direction. In regard, I want to also tell that this, consistent mass matrix, it gives more accurate results than these two. Why? Because when lumped mass matrix is used, a portion of the structure's mass is allocated to the supports and therefore not taken into account for seismic calculation. For these two cases, it is very important points. Okay, now let's move for these active mass directions. What it is? Here it says allow the user to specify in which direction masses are allowed to act. In principle, all directions are active mass direction, but sometimes it may be desired to check specific direction only. For an example, this vertical mass direction can generally be neglected. Unless there is a specific interest in looking into effect. When the vertical mass direction is active, it will give vertical modes. Sometimes it is disturbing. Especially when slabs are not held by columns for long distances, and so they are free to oscillate vertically. Anyway, let's move for the next. Disregard density. Here what she says, disable the automatic consideration of self weight. Basically software, it calculates, it converts self weight to mass. That is why we must put this disregard density as this one. If I put here tick, then self weight will be counted twice, so we don't want that. So let's move next. We can click on this. So keep it in mind, we put 18. So press OK. Now load to mass conversions. As I said, dead load, this conversion, it will be done by software itself and it will happen automatically. So we will start from dead load 2. It is actually superimposed dead load. So click here, press this, you got cases 2, add it here. So it is added. Now question is, what about this conversion directions? That is very important. Conversion directions, it is showing here Z minus. Why Z minus? Because in the vast majority of cases, we will leave this set to Z minus to account for gravity structural loads. So keep like that. What about the constant? Not constant, this coefficient. So regarding this coefficient, we can adjust the contribution of masses by using this coefficient. So what we will do, for the dead load we will consider it is 1, for live load we will consider some percentage. So here, as it is a dead load, superimposed dead load, we put it as 1. So all are okay. And this mass direction, unless there are some special circumstances, the mass will act in all directions. So we leave like that. Add to mass, global mass, there is dynamic mass. Dynamic mass means it only active for dynamic cases, but for global mass, it is active for any load cases, including static ones. So we should take this global mass. So leave that. So we are done. For this case, add it. Now go for another case, third one, live load. Click here, it will be added and it will come here. Keep this direction, mass direction, add to mass as it is. Only here we will change this percentage of coefficient, say 3.3, 30%. So add this. Again for snow load, adding the cases, close it, it will appear here. Leave all other as it is, only changing these to 0.3. So add it. So we are done with load to mass conversions. So we are okay now up to these points. Now we have to create the seismic case. Seismic case creation. How to do that? Go analysis type, click new and click here seismic NBC of Canada 2010, or you can use tool this menu bar, then you can go preferences, job preferences, then you will get the codes. But here I am leaving as it is. So click here on Seismic and press OK. So we got it. What we got? This is site class C having FA. FA means acceleration based site coefficient. It is equal to 1 for site class C. Again for FV, velocity based site coefficients equal to 1 for site class C. Now let's concentrate on this direction definitions. Why 2? Because we have to think of, let's click here and okay. Here I am taking direction X and Y, not Z. Put here 0. So here if we look at quadratic combinations, numeric combinations. So what is happening? Here it is CQC. CQC combination between modes, and this is actually complete quadratic combinations. We can see here complete quadratic combination, and this is CQC, complete quadratic combinations. Now if we think of using combinations between directions, it can be this one or this one. To use this one, how to get that? If we put here tick, automatically all are active now. All are active with CQC. This is one way. But in other way, which one will do it right now? Combinations between directions, or to use numeric combinations. So let this deselect and numeric combinations. So we are setting this numeric combination by clicking group 1 and group 2. Right away CQC will be active. CQC, I told, it is complete quadratic combinations. So once this CQC active, so we are done here. Click OK. Then here OK. Now it will be created here. Look at two seismic case in the direction of X and Y are here created, and as well linear, 4 linear combinations we got here. Now we will generate chord combinations. So we will generate chord combinations. How it will come? So what we will do? We will generate the automatic chord combinations. So let's close this and go for loads. Click automatic combinations. Here choose full automatic combinations. We need that. Now click on more. We don't want this. Okay. So here these cases, deselect these two, 8 and 9. Relations, nature, go for seismic. Now generate. Now go for calculations. It will take some time. It's going fast. Yes. Going to be finished right now. Maybe some seconds. Yeah. It is now at the end. So we are done here. So let's see combination table. We got this. We can get more if we put table column and code combination components. Okay, so we'll get full. We got all 1 to 19. If we put here modal, no, leave like that. So even code combinations, yes. So we got this. Now basically code combinations. If we look here, we can see all. This one 8 9 8 9 8 9. Here we can see that. Okay, now this is creation of code combinations. I mean, this is combinations. Now what we'll do, say we need to analyze results and verifications. So what you can do, let's go for the view. So we need, say, modal. So at these situations, what we need, here we click results, advanced modal analysis. So we got it. Cumulative masses percentage. If you look at 90 90 90 90 90 90, very perfect. 90 90 90 92 92 92. As well, this frequency must be above 5. If we look at, must be above 5. And another important thing here, so Mass participation also we saw. Total mass we have seen. Now one interesting things I will do. It is I will, and even if you can see that this is with total mass, I want to add some column here. But before that, what I'll do, I'll click analysis type, and here what I'll do, this combination sign, I'll click here. So what to do? If you look at this, current mass, what it is? You see maximum, it is here. What it is called? Dominant mode is here. So what is that number? 67.64. This is the dominant mode. Let's see here. I'll click on top. Then we can see. So dominant mode, this one, dominant mode is number 3. Here you can see this is 67.64. This is the dominant mode, number 3. So why? This is for X, so direction X. So click here, here you put 3, then set it. It will change this made mode number, instead 0 it will be 3 now. Got it. Now for 9, for direction Y, look at here. It was 3, but this is 2. So here I am putting 2. Set it. So it is done. Now what to do? Go for calculations. We have to wait for some time. It will be done fast. Going to be finished. So it is done. 1818. Okay. So I got this. Now I can do here something, say table column. I will add some column here. This one, eigenvalue, no need. This is no need. Say you can go special coefficient, click here, So okay, now look at these three columns are added. Right now it is added, this one, and this one. So we can close this. Right now we can see something. Say we are checking results. So what we will do right now, better we see now first this one. Say calculation notes, simple notes, simplified notes. So you can go through this all data, and from here starting this one, Seismic Canadian NBC 20 direction X, this excitation directions, this is acceleration versus periods, and this is also acceleration direction Y, and all other values are here. So we got it, this one, yeah. So we got it. Now we have one important thing. Say if I click on reactions, say I click on reactions, what is happening here? If I click here, say this is very interesting thing, I'll show you right now. You can see here this dead load, sum of reactions, this dead load 2, sum of reaction, this dead load 3, dead load 3 means live load 1, sum of reactions here, as well as snow load we have sum of reactions. So these four, if I add, say I want to add this, so what I did in Excel sheet, I added, you see here 44604 I took from dead load, then I took from here also 10710, then I took this 34272, then I took this one, here also we have 1666, and this value I have taken from here. If you remember this analysis type, combination sign, not combination sign, sorry, load to mass, look at this coefficient 1.3, 0.4, 1.3, 0.4, these three I got it here. Yeah, this one for the self weight, this is for superimpose, this is for live load, this is for snow load. So I took from here, multiplying these two, because this I took from this one, this reactions table, and this is from here, multiplying this I got these results, adding I got 66,096 kilonewton. So let's see our these results. Definition of dynamic analysis results. Let's look at, keep it in your mind, 66,096. But when we got these results, say this one, what is the mass? 672274. This is kg. But our result was this one. I already took this value, 6622749 kg. Kg multiplied by 0.009807, then you got this as a kilonewton. How much it is? So instead of this value, I can say this here as kilonewton, but look at my value, very close. 659 means I can say it is 66,000, very close to this 66,096. That I got from reactions. I took this, and from here I took coefficient, multiplying, then adding, I got this. This is really the total mass what I got in this one dynamic analysis result, and it is also same value from here. These and these are same. So I think that's all for this video. So we are done.